If you've ever played Super Mario, you know that awesome feeling of grabbing a fire flower, right? In a split second, Mario gets a whole new power. Well, what's amazing is that researchers have found a way to do pretty much the same thing with AI models, letting them absorb brand new abilities in a way that's, well, it's surprisingly simple. And look, this isn't just a cute analogy. It's the real question behind a totally groundbreaking new technique. I mean, imagine taking one AI that's great at conversation, another one that's a math genius, and a third that's a master at coding, and just, merging them into one supermodel. Sounds easy enough, right? But in reality, it's been a massive headache for AI developers. The reason it's so tough is this thing called parameter interference. When you try to just mash up the programming of two specialized models, their skills don't just add together nicely. They clash. They interfere with each other. It's kind of like trying to speak two languages at the exact same time. You just end up with nonsense. The new model often forgets how to do either of the things its parents were good at. It just breaks. So in this explainer, we're going to walk through how researchers finally cracked this problem. We'll start with the absolutely wild secret they found about how AI learns. Then we'll look at the elegant solution they built called DAR. We'll see how it merges skills without all that conflict. And finally, we'll get into why people are calling this a free lunch in the world of AI. Okay, so the first clue to cracking this whole thing came from looking at what actually happens inside a model when it learns something new. And the key, it turns out, is something called delta parameters. So think about it like this. When you take a base model, let's say Lama 2, and you fine-tune it to be amazing at math, you're not rewriting the whole thing from scratch. Nope. You're just making millions of tiny little tweaks. The delta parameters are simply the difference between the original model and the newly tuned one. It's the pure, distilled essence of that new math skill. And this is where it gets absolutely wild. When the researchers looked closely at these delta parameters, the essence of the skill, they found that the vast majority of them, up to 99%, were basically useless, redundant. You could just throw them away and the model would still know how to do its new trick. This graph right here shows that discovery in action, and it's just incredible. Take a look at the green line. That's for a monster 70 billion parameter model. The axis along the bottom is the drop rate, basically how many of those delta parameters are being deleted, and the performance is on the side. Just look at it. Performance stays almost perfectly flat until you hit a staggering 99% drop rate. This finding is it's radical. The essence of a new skill is packed into a tiny fraction of the changes. So, that insane discovery leads us right to the solution. This technique they call DARE. And it is built on that totally backward idea that to make models stronger when you combine them, you first have to throw most of their specialized knowledge right out the window. DARE actually stands for drop and rescale, and it's a beautiful two-step process. First, you take the delta parameters for a skill, like math, and you just randomly drop 90 to 99% of them. Poof, gone. Set them to 0. But then, and this is the magic trick, you take the tiny handful that are left and you rescale them, which basically means you boost their strength to make up for all the ones you just deleted. And I gotta stress, you can't just do the first step. If you only drop them, like you see in the drop-only example here, the model's performance just tanks. It completely falls apart. That rescaling step, that's the secret sauce. It makes sure the overall impact of the skill is still there, even though it's now being carried by a much smaller, sparser team of parameters. And just like that, we've solved our big problem from the beginning. By using DARE on each specialized model before you try to smush them together, you get rid of that nasty parameter interference. This is how you avoid that gibberish we talked about and instead create a model that can speak multiple languages fluently. Because each skill has been trimmed down to its tiny, essential core, there is almost nothing left to clash when you merge them. I mean, just look at the slide. On the right, that's the old way. You try to merge a math brain and a code brain, and you get those sad faces. It's a broken mess. But on the left, that's the DARE method. You apply DARE to both models first, and when they merge, boom, a single, happy, superpowered model that is now a pro at both tasks. Okay, but hold on, because this is where the story goes from clever to absolutely incredible. The merged model isn't just a simple compromise. It's not just as good as the originals. The researchers found that the new merged model could actually become better than any of the individual models it was made from. I mean, check out the numbers for yourself. The specialist coding model scores a 27.6 on its own, but merge it with a general model using DARE, and the new score jumps up to 33. Same thing for math. The specialist gets a 64.2, but the merged model hits 66.2. In every single case, the combination created something that was greater than the sum of its parts. And that is why the researchers call this a free lunch. You get a much more powerful, more capable model without any of the usual costs. You don't need to do any expensive retraining. You don't need a farm of powerful GPUs for this merging process. It's just basic arithmetic you can do on a regular old CPU. It's a huge performance boost for practically zero cost. And if you need the ultimate proof, here it is. The researchers took this technique, created a model, and of course they named it Super Mario V2. And what happened? As of late January 2024, it shot straight to the #1 spot on the competitive Open LLM leaderboard for its size class, beating everybody else. This isn't just a theory in a lab. This thing is a world champion. So let's wrap this up. What's the big takeaway here? It means we now have a super cheap, incredibly efficient, and really accessible way to create custom, multi-talented AI models. This kind of power is no longer just in the hands of the big tech giants with massive server farms. It really lowers the barrier for everyone to build powerful, customized AI. This just throws the doors wide open for what's possible. What happens when you merge an AI that understands medical research with one that's an expert in chemistry, or a model that writes amazing stories with one that can generate music? The era of AI power-ups is officially here, and it leaves us with one really exciting question. What are we going to build with it? This is for entertainment purposes only.